Okay, under topic 1, matter. For learning outcome 1.2b, determine empirical and molecular formula from mass composition or combustion data. So how to determine the empirical formula? There are 3 methods. So the first one, by using the masses of compounds. Second method, by using percentage of composition of a compound. And the last method, by using the combustion data, which is elemental analysis data. Now we are focused on the last method, method 3, which is by using the combustion data. So we're looking at the example. So refer to the example 3, 1.00 gram sample of organic compound A was burned in excess of oxygen. The combustion produced 2.52 gram of carbon dioxide and 0.443 gram of water. Determine the empirical formula of the organic compound A. So let's see the solution. The first step to solve these questions is to find the mass of each element involved. So the element involved in these questions are carbon, hydrogen, and oxygen. So to find the mass of carbon, so in 1 mole of carbon dioxide, there is 1 mole of carbon. Therefore, 12 gram of carbon divided with 44.0 gram of carbon dioxide multiplied with 2.52 gram of carbon dioxide. So you will get the mass of carbon equal to 0.688 gram. The second step is to find the mass of hydrogen. So how to find the mass of hydrogen? So again, in 1 mole of water molecule, there are 2 moles of hydrogen atoms. Therefore, the mass of hydrogen is equal to 2 gram hydrogen divided with 18.0 gram water molecule multiplied with 0.443 gram of water molecules. So you will get the answer 0.0492 gram of hydrogen. So the last element is oxygen. So to find the mass of oxygen, we can simply use the mass of sample given in the equation minus mass of carbon with mass of hydrogen. So the mass of sample given is 1.00 gram minus mass of carbon 0.688 gram with mass of hydrogen 0.0492 gram. So you will get the answer 0.263 gram of oxygen. So now we get the mass of each element. Okay, mass of carbon, mass of hydrogen, and mass of oxygen. Okay, the next step, after all the masses of each compound obtained, build up the table to get the empirical formula. Okay, in the constructed table, so make sure you get the element, mass in gram unit, amount or mole, and simplest ratio of relative amount. So the first row, mass for each element, so carbon, hydrogen, and oxygen. So take the mass we calculated in the first step before. So carbon 0.688, hydrogen 0.0492, and oxygen 0.263 gram. So After you put the mass in the first row of the table, we goes to the second row. So this is amount or mole. So to find the mole for each element, so take out the mass, divide with the molar mass of the element. So for carbon, 0.688 gram divide with 12 gram per mole, so equal to 0.0573 mole. For hydrogen, 0.0492 divide with 1 gram per mole, equal to 0.0492 mole, and for oxygen, 0.263 divide with 16 gram per mole, equal to 0.0164 mole. We go to the last row of the table, which is simplest ratio of relative amount. So to find the simplest ratio, okay, take out the mole calculated in the second row, divide with the smallest number of mole of the compounds. So the smallest mole of the compounds in the second row is oxygen, which is 0.0164. Therefore, the simplest ratio of carbon is mole of carbon 0.0573 divide with the number of mole of oxygen, because this is the smallest number of mole, so 0.0164, so you get the answer 3.49. Approximately is 3.5. Okay, the next element is hydrogen. So take out the mole of hydrogen, which is 0.0492 divide with number of mole of oxygen, 0.0164 equal to 3, and the last one is oxygen, 0.0164 divide with 0.0164 equal to 1. Okay, this one for carbon 3.49, so round off to get the times with any number to get the whole number. Okay, let's say carbon 3.49, so times with 2, so you get the whole number is 7. So for hydrogen, you got 3, also multiply with 2, and for oxygen, 1 multiply with 2. Therefore, now the simplest ratio for carbon is 7, for hydrogen is 6, and for oxygen is 2. So the empirical formula for the compound A is C7H6 and O2.